Hello, everyone. On behalf of my colleagues, welcome to this month's talk from the Johns Hopkins Institute for Assured Autonomy seminar series, co-sponsored by the Computer Science Department of the Whiting School of Engineering. Each month, we'll have a talk on research topics at the intersection of assurance and autonomy. This seminar will be recorded. Today's speaker is Kush Varney. Dr. Varshney is a distinguished research staff member and manager with IBM Research at the Thomas J. Watson Research Center, Yorktown Heights, New York, where he leads the machine learning group in the Foundations of Trustworthy AI department. He was a visiting scientist at IBM Research Africa in Kenya in 2019. He is the founding co-director of the IBM Science for Social Good initiative. Dr. Varshney applies data science and predictive analytics to human capital management, healthcare, olfaction, computational creativity, public affairs, international development, and algorithmic fairness. His recognitions include the 2013 Gerstner Award for Client Excellence and Contributions to the WellPoint team, and the Extraordinary IBM Research Technical Accomplishment for contributions to workforce innovation and enterprise transformation. Dr. Varshney's academic research focuses on the theory and methods of trustworthy machine learning. His work has been recognized through Best Paper Awards at the Fusion 2019, SOLI 2013, KDD 2014, and SDM 2015 conferences. Dr. Varshney received the BS degree, magna cum laude, in electrical and computer engineering with honors from Cornell University, the SM degree and the PhD degree in electrical engineering and computer science from the Massachusetts Institute of Technology. He self-published a book entitled Trustworthy Machine Learning in 2021. He is a senior member of the IEEE. Dr. Varshney's talk is A Carative Approach to AI Governance. Kush, thank you for joining us, and over to you.
Great, thanks, Ken, and it's my pleasure to be here. Thanks for the invitation. So let me share my screen and we can get going. All right. Excellent. Yep, so the title of the talk is A Carative Approach to AI Governance, and I'll explain what that means as we go along. Right? So first about this first word, carative. Most of you, or probably all of you, have never heard this term before. So it relates to the distinction between curing and caring. So on the left, we see a doctor who's trying to cure a patient, doing whatever that they do. And then on the right, we have a nurse who's looking into the eyes of the patient and is trying to take a holistic sort of approach, so a caring approach to get the patient to be healthy. So this image is from the Wall Street Journal. The fact that it's a man who's a doctor and a woman who's the nurse is something that I'll come back to later on, right? Just keep this in mind. What is this word carative? So I'll come back to it in the last third of the talk. Okay? So the topic that we're talking about, AI governance, it's related to trustworthy machine learning and so forth. And in the typical sort of way that you would talk about things and build things up, you would start at the bottom. So talking about what is supervised learning, and then come to things like fairness and robustness and explainability, and then testing and transparency and governance at the end. But for the purposes of today's talk, what I'm going to do is actually start at the top and talk about governance and come down as necessary. Okay. All right. And then I'll also do what's called a positionality statement. So again, this is something that most of you probably have not heard or seen before. So this is actually pretty common in the social sciences, and it's a positionality statement tells the audience kind of where the author or the speaker is coming from. So most of the time in engineering, it's like it shouldn't even matter, right? What your personal background is, because that should it's thought that it should be irrelevant to the research or to the topic. But when you're actually doing things that have socio-technical sort of nature, it's actually important to understand the presenter, the author's background as well, right? So very quickly, so all the way on the left, this is a sign from what was called the PASA Fund Glassworks. So this was the first industrial scale glassmaking factory in India. So it was actually established by my great-great-grandfather. And he was the first Indian to study at MIT back in 1905. And this factory was used to actually not only showcase how local industry could be successful, and it was used kind of in a manner to promote social justice and what was called Swaraj, which is the idea that India should be independent from the British. So it was kind of using technology to advance the social goal, right? And then that was on my mom's side, and on my dad's side, my grandfather, he was a professor of agricultural engineering at the first Department of Agricultural Engineering outside of North America, which was at the Allahabad Agricultural Institute, also in India. And again, using technology and sort of advanced science to improve society, but also more broadly than that. So Mahatma Gandhi actually used to hang around once in a while at this place and kind of learned things that he also used to uplift society, right? And then in terms of my personal sort of background, as Ken mentioned, so I did start as an electrical engineer, kind of more in a signal processing sort of background. And then for the last 12 years, I've been working at IBM Research. And I wasn't personally involved in the IBM Watson, the Jeopardy sort of thing, which was already well underway when I just joined, but it's kind of had an impact on kind of where I've headed and what work I've done, right? So let me just see if, okay. All right, so one other thing about the positionality. So I kind of take more of engineering sort of approach to things. What can we do as the developers of the technology rather than an activist sort of approach, right? So an analogy to this is back in the late 1800s, processed food was really new and kind of a novel technology at the time that, oh, you can buy food that's already been made, right? So Henry Heinz had started the Heinz company and was selling ketchup in clear glass containers with free factory tours and a lot of innovation on sanitation and so forth. So he was trying to make processed food very trustworthy at the time. And there was the other approach happening at the time as well, which is called muckraking, epitomized by this novel by Upton Sinclair called The Jungle. So it was finding all the bad stuff that was happening with processed food, like all sorts of adulteration and fillers and all sorts of bad stuff, right? So again, with AI, same thing. There's people out there that are kind of figuring out what is wrong, kind of shining the light on the ills. I tend to take more of the engineering approach. What can we do? What can we innovate to make things better? All right. So now coming to AI governance, right? So what is a governor, right? So a governor is a device to measure and regulate a machine, also known as a controller, right? So this is a controller for a steam engine. Okay. So then governance is the act or process of overseeing the control and direction of something. And these days we're hearing this term AI governance quite a bit. There's lots of definitions floating around, and usually it refers in some capacity to responsible or trustworthy AI, some of the things I'd shown earlier. And it's usually focused on the kind of technologies that are related to making decisions about people like lending or hiring or criminal justice, healthcare, and so forth. But not on cyber physical systems. So usually not talking about robots and self-driving cars and robotic surgery and things like that. Okay. Yeah, governance might refer to laws and regulations. It might be quite philosophical. Uh, but I mean, there's a lot of things that are, happening. But what I want to do is actually come back to my engineering roots and think about governance and AI governance exactly as an engineer would through control theory. Okay. So this is a picture of a typical control system that hopefully many of you have seen before. So there's some reference signal, there's some sensor that's measuring some output, there's a system that is producing that output, and then there's a controller that's providing the input so that that system meets the reference and so forth, right? So how does that apply, or what does that mean for machine learning systems, right? So this is a somewhat interesting, different sort of control theory perspective on machine learning systems. So we have a machine learning model, and the process of training that model, developing that model, is the role of data scientists. So they're kind of like the controllers, okay? The machine learning model gets created, you test it, and it produces facts. And those facts should have some alignment with some sort of values that society has said that they should. So this question of what those values are is a societal sort of thing, setting the reference. We designed the system just for it to make sure that it's actually meeting those values. Okay, and I'll explain what kind of values I'm talking about as we go along. And the values themselves are this guiding light for the machine learning model, but there's actually something even broader than that, and those are principles. So there's a process of eliciting values from people in society that translates those principles along with the context of a particular problem into values. Okay. All right, so for much of the rest of the talk, this is the outline. So I'll start with principles, then value elicitation, testing, facts, and then the data scientists themselves. Okay. All right, so what are we talking about when we say principles, right? So there's many sets of AI ethics principles that have come out from different organizations over the last maybe 3 or 4 years. Okay. So they've come out from different types of organizations, whether it's private industry, governments, or civil society. They are often, and the large majority, coming from economically developed countries, and they're often, really often based on Western philosophy. Okay, so those second two bullets, so the second and third bullet might, give us pause, but again, this is just the fact as it is, right? So if you analyze all of these different ethics principles coming from all of these types of organizations, there's 5 common coarse-grained principles that tend to emerge. Okay? One of them is privacy. Second is fairness and justice. Third is safety and reliability. Fourth is transparency, which can be transparency about an overall system, also about the model itself. So can a human understand how it makes its predictions? And then the fifth is social responsibility or beneficence. Okay. There are differences across the sectors. So governments tend to emphasize beyond those 5 core principles, things like economic growth and productive employment. They also might refer to competing with other countries in terms of their AI and other countries' AI. Right? Private industry mainly sticks just to those common principles, and some people argue that companies putting out these ethics principles is what's called ethics washing, that it's just a performative sort of thing where they're just doing it so that they deflect criticism, right? And then civil society, which kind of exists. So these are not NGOs and other organizations like that. They kind of exist as a criticism to government and private industry, because if government and private industry was doing everything right, there would actually be no need for civil society. So as as a critical sort of part of the world, a lot of the ethics principles coming from civil society are rooted in critical theory, and also emphasize the shifting of power from the more powerful to the vulnerable. Okay. All right, so if those are the starting principles, what next do we need to do in order to get to actual values that can be tested for, right? All right, so value elicitation uses the principles as a starting point to specify the desired behavior of our system, right? And in my mind, there's kind of 4 levels of elicitation. So the first is, should you even work on a problem? Second is, which pillars of trustworthiness are of concern? Third is, what are appropriate metrics for those pillars of trustworthiness? And then the last is, what are acceptable ranges of the values of those metrics? Okay. So let's go through those one by one. Right? So first question, should you even work on a problem? All right. So sometimes the answer is actually no. So one example of this is like IBM a couple of years ago came out strongly to say that we as a company would not work on face recognition technologies. Okay. All right. So what are some of the things that you should think about as you're thinking about whether you should or should not work on a problem? Okay. So if the system helps subvert the truth, if it is addictive, if it exacerbates economic inequality, if it amplifies social biases, if it represses dissent, if it causes people to lose control of their data, if it does things that users don't know about, if it makes bullying or fraud or theft easier, those are maybe things that are reasons that you should not work on a problem, right? But again, values are not universal, right? So many of us might say that if any of these are true, that that's the reason not to work on a problem, but that's not always the case, right? So everyone has their own sort of values, okay? So when we're trying to elicit those values, it's good to have some sort of formalism around them. So there's something called CP nets. So this stands for conditional preference networks, and they're very similar to causal graphs or Bayesian networks and things like that, right? So if someone does believe that if any of those is true, then you should not work on the problem. It's like a logical OR, and it's a very simple CP net, which is shown on the screen. So it has a graphical model as well as these conditional preference tables. I just bring this up because if there's more complicated things, it's good to reason this way, right? But again, I mean, maybe someone has a different belief, right? Maybe you could believe that if economic inequality is not being exacerbated, then it's okay for there to be some algorithmic bias or something like that. Okay. All right. So yeah, I guess there was a question. So in the list of stakeholder society refer to organizations, what about the public and individuals as an entity, right? Yeah, let me address that right now. So the public is presumably represented by government. If that's true or not, that's another story. Public, I mean, the general public acting without an organization, I mean, could be then seen as part of civil society as well. So yeah, I agree. I mean, there doesn't have to be an organization per se, but the point of view would hopefully be captured by one of these types of organizations. All right. Okay, so that was the first sort of question. Should we even work on a problem? Second question is, if we are going to be moving ahead and working on a particular problem, what should we care about in terms of how this model behaves or performs, okay? So assuming that accuracy is always something that we would want to work on, that we want to be important, our question is, among these other sort of pillars of trustworthiness, things like fairness, explainability, uncertainty quantification, distributional robustness, adversarial robustness, and privacy, which ones are important, which ones are maybe less relevant for a given use case, okay? And if you ask people directly, it's very hard for them to tell you like do I care actually about explainability or not? I don't know, right? So, and this is the policymakers and stuff that you're asking, okay? So it's sometimes easier to ask a little questions that are a little bit closer to what they're used to knowing about, right? So these are some examples of questions. So is there a possibility of giving systematic disadvantage to certain groups or individuals? Is there a regulator auditing the model, or people, is there a human decision maker involved? Will the model be retrained? Is the data about people? Are there other security measures that have been undertaken, etc. Right? So again, you can create a CP-net for this. Again, this is not universal, but just illustrative. So as an example, if we look at fairness, if there's a possibility of systematic disadvantage against certain groups and individuals, and if the data is about people, then maybe we do care about fairness. If the system is going to be retrained frequently, then maybe we don't care about distributional robustness and so forth, right? And again, there's a conditional preference table associated with this, which you can draw. This is one example. And when you then ask people about their answers to the higher level question, then you get the answers through a very simple inference of which of these pillars of trust are the ones that are important for that particular use case. All right. Then third level of question is what are the appropriate metrics for those pillars of trustworthiness? And here, different sorts of worldviews play an important role. So just as an example, for fairness metrics, there are actually several different types of fairness metrics. Some are more and less relevant depending on what situation that you're in. So there's one called statistical parity difference, and that's relevant when there is social bias in the features. So an example of that is, let's say we look at the SAT score, and the verbal section has a reading comprehension passage which relies on some, or the passage itself is about some cultural phenomenon or something. So if you as a human have some knowledge of that cultural aspect of it, it's easier for you to answer the questions. And so the score might not be truly representative of your actual ability to succeed in college. Another example is in the US healthcare system, for a variety of reasons, African Americans utilize the healthcare system less for the same level of how sick they are. So if the feature is healthcare utilization or healthcare cost, it might not be, it might have social bias in terms of healthcare need, right? So if there is social bias, statistical parity difference is a good fairness metric. If there is not, then some other fairness metrics like average odds difference, average predictive value difference are better. And then among them is the the outcome favorable? Is the favorable outcome assistive or just non-punitive? So assistive things are getting hired, getting a loan, things like that. Non-punitive things are not getting fired, not getting arrested, things like that. Okay. And I mean, just thinking through all of this also is complicated. So until someone works with you to think about if there is social bias, if what is a favorable label, things like that, it's hard to go about it. So an alternative is actually showing you different confusion matrices. So matrices of false negative and false positive and true negative and true positive rates. And there's actually ways to show these in sequence that allow you to actually elicit directly what was in the mind of the person just based on these pairwise comparisons. Then moving to the fourth level, so once we've chosen the metrics themselves, what are the actual ranges of those that are acceptable, right? So in the first three levels, we didn't need to think about more than one dimension at a time, but when we're thinking about the ranges of values, it is actually important to do so. because there's trade-offs and non-trade-offs among these things. So if you ask someone, do you want your model to be 100% accurate? They'll say yes. Do you want it to be perfectly fair? They'll say yes. Do you want it to be perfectly robust? They'll say yes, right? But we know there has to be constraints. There's only certain feasible things that one single system is able to achieve. So it's actually an open area of research to characterize this feasible set of models that, in terms of all of these different dimensions of trustworthiness. So we're actually working on this using an information theoretic approach, using something called chernoff information, right? But it's very open on how to do this, right? And when you're asking people again, I mean, there has to be some visual or something that they can relate to. So you can create actually many different models, visualize the space of what's possible, potentially using something called parallel coordinate plots, and then show that these are things that could be done, and then that gives the user some ability to say, oh, this is. Another way to do this solicitation is a variation on what's called trolley problems. So if you kind of show two scenarios that people are able to relate to in a way, in a context that they're familiar with, then they can tell you which do they prefer. So did someone from an unprivileged group have more or less sort of favorable labels? Was there an adversarial example, and so forth? Let me just check the chat. Okay. All right. So the other sort of thing to say about this elicitation step is about eliciting from a single user versus eliciting from a group. So it does make sense to elicit these values from a group of stakeholders, and this relates kind of to the earlier question as well. And often we want to include affected users from vulnerable communities in making these determinations as well. So when we look at CP-nets or pairwise comparisons, and we look at the academic literature, aggregation methods are fully based on things that boil down to voting in some sense. And the problem with doing it that way is that minority voices might raise these important concerns that would be drowned out by the majority if it was just a voting scheme. So potentially better way to do this is through facilitated participatory design sessions where you bring the people together and they together complete these comparisons for CP-nets and so forth. All right. All right, so next part of this control theory diagram that I wanted to talk about is the testing aspect, right? So testing of machine learning systems is different from regular software testing. And the reason is what's known as the oracle problem. So you don't know actually what the right answer is supposed to be, because in machine learning, the whole idea is to generalize. So for a new unlabeled input, you don't know what the right input, the right label is supposed to be. Okay, so one way around that is what's called metamorphic relations. So this is the idea that if you have two inputs that you don't know what the predicted outcome is supposed to be, but you know that for both of those inputs, it should give you the same output, right? So those are ways to kind of test machine learning systems. So you can multiply all the features by a constant and do that. You can change one of the attributes in such a way that you know, or that you hope that it should have the same output. So in fairness, that's one way to do it. So you have two feature vectors that are exactly the same, except one is male and one is female. And if they don't get the same output, that's an issue. Okay. And it's an open problem of how to best generate test cases for machine learning. So using adversarial examples is one way to do it. So these are small perturbations that kind of change the label, but how to do this in a way that provides good coverage is a very open problem. Okay. One other thing to say about testing is that it should be accompanied by uncertainty quantification. So not just test in the average case, but get those confidence bounds. And we should not be doing this just for accuracy, but for all of those trust-related metrics that we talked about. And uncertainty quantification is a way to inject some kind of intellectual humility into into this process. So the system itself is reporting its own limitations, which is something that I think is important. All right. Then once that testing has been done, we need to capture that. So one thing that we've proposed is called fact sheets. So this is a way to have the technological backend that will actually capture all the stuff that's happening in a development lifecycle. So whether that is quantitative tests, qualitative information, and so forth throughout different phases of things that are happening. And then as those are collected, then you can actually render them out into different forms for different consumers. So those could be very detailed things for data scientists. They could be some conformity assessments for regulators and so forth. Last thing to say is on the data scientists themselves, right? So people are involved in every part of this life cycle. So there's different personas that are involved, whether it's in the problem specification, the data understanding, data preparation, modeling, evaluation, or the deployment. And there's the set of diverse stakeholders all the way on the left, which is usually not drawn on pictures like this, right? And I'll explain who they are in a second. So it's often said that having diverse teams is good, but that's a very sort of rough way of saying things, right? So why is that actually the case, right? One could say that maybe it's good for some reason, but what are those reasons, right? So there's actually two things why this is important, right? So the first is that if you personally have experienced some sort of marginalization or some sort of oppression or some sort of harms in your own life, you actually have what's called an epistemic advantage. So that means that you're better able to spot issues and spot harms that are happening by the application of some system, not just for your own experience or your own group, but for all groups, okay? So that's one reason to bring in diverse stakeholders. Second is that diversity actually helps a team slow down and be more deliberative. So even if all team members were trained at Johns Hopkins, know exactly the same set of stuff, if they're all socioculturally homogenous, they'll kind of just agree without deliberating. But if they're socioculturally diverse, then they'll stop and talk more and deliberate. So those are two reasons why diversity is actually useful in doing better, right? So then the question is it equally useful in all parts of this life cycle, right? And I would say actually no. So it's most useful in the problem specification and data understanding phases when you're trying to answer those questions, elicit the values and so forth, and then understand the data, because that's where you can say, oh, this is how we should do it. This is what we should care about. These are the harms that could arise and so forth. And also in the evaluation phase. So again, once you have a system to identify, oh, this is what, how it could be misused, how it could go wrong, how it's underperforming and so forth. So that's where the epistemic advantage is the most useful. When you're in the modeling and data preparation phases, as well as the monitoring phases, it's less useful, because if you give a clean and very precise problem specification, then any skilled data scientist should be able to follow it and meet those requirements. And similarly for operations engineers who are monitoring and so forth. Okay, so I kind of covered all of these different parts of the control theory picture, but there's something that's been missing throughout everything that I've said, right? And what's been missing is the following, right? So it was all stated very much in a technical sort of approach. Even when I was talking about values, those values were eventually translated into numerical things, metrics, and so forth, right? So what it wasn't doing was taking this more caring sort of approach, okay? And I'll get into what I mean by that, okay? Just a quick aside, so this word carative was coined by a famous nursing theorist named Jean Watson. So we're kind of contrasting Watson with Watson in a sense, right? Another sort of view on this is in philosophy and ethics, there's two kind of branches, although there are others, but two main branches of ethics. One is called consequentialism and one is called deontology. So consequentialism is all about outcomes, right? So no matter what the process was or what the actions were, we care about the outcomes in terms of what's good and what's not. Deontology is the opposite. So we don't care what the outcomes are, but the ethics are based on the actions themselves. So are we doing good actions without thinking about the outcomes, right? So when we think about this control theory view, the pillars of trust, quantitative test results, and acceptable ranges of metrics, all of this seems to be a very consequentialist flavor, right? And that's not what care is, right? So this is a quote from Anne-Marie Slaughter. So care is a duty. We must take care of our planet and our family members, or else it is a service to be paid for. We can buy carbon credits to offset our pleasurable consumption and hire others to feed, bathe, dress, and drive those we love. Care is not a service, but a relationship that depends on human connection. The quality and depth of our relationships with others are essential to our longevity, well-being, and brain development, and to our very humanity, right? So we do need both, the curing and the caring, but we often devalue the second. So coming back to that Wall Street Journal picture, right, it was the woman who was the nurse, and it's very common to see caring professions as devalued or of lower value, and that is a big problem as we're thinking about kind of if we want to bring caring into AI and how to do this, right? So I'm not going to say more on that, but just keep it in the back of your mind that the more we kind of devalue caring professions, caring work, it's not going to actually lead us into the place that we need it to. Right? All right, so now if we're in this deontology sort of world, the opposite, where we do want to have moral imperative, that we do go and do the holistic sort of thing, what is it that we're actually doing, right? So there's this concept of accompaniment, and this is the thought that you need to journey with the marginalized literally and figuratively until justice is achieved. And from a nursing theory perspective, what we're saying is that we need to have kindness and equanimity by treating all patients as they are and respecting their values, even if they're different from yours, right? So this is what kind of the deontology viewpoint implies, right? So what would be a curative approach to developing AI systems, right? So what we should do is start with a real world problem as experienced by the most vulnerable people, right? So listen to them, understand their values, and then only start and work on whatever it is that you're working on, right? Importantly, meet the people where they are and work toward a solution to their problem all the way to the end. And even if that involves a lot of grunt work and doesn't lead to a flashy paper at NeurIPS or ICML or whatever at the end, right? So, I mean, don't be like, I will only do this part of the problem. This is the only interesting part and stuff. Really solve the problem as it's given to you, as experienced by those the people who you're doing it for, right? And then also collect qualitative facts in addition to the quantitative sort of facts in a fact sheet, and also conduct a qualitative assessment of the entire solution by interviewing the affected communities to see whether you actually did well or not, right? So let me give an example of this. So this is a project that I worked on in collaboration with a social enterprise named Simpa Networks. So these are all photos that I took in a village named Barauli. So this is about 18 kilometers from Aligarh in Uttar Pradesh in India, which is where my family is. The bigger city is where my family is originally from, actually. Right? So what Simpa Networks does, so there's a solar panel in these pictures on the roof of an individual house. And this is a transformer that actually you connect to the load and it connects to the solar panels on the roof, right? So what does Simpa Networks do? So they do what's called pay-as-you-go solar power. So this is the idea that poor people who live in areas with unreliable grid power can obtain solar panels for their homes, right? So these are people who aren't like so poor that they can't afford a solar panel. It's just they'd never have enough capital at any one time to pay for all of it at once, right? So what Simpa does is it allows them to put down a small down payment and then provide incremental payments over 2 to 3 years until they've fully repaid for their system, okay? So the amount that they have to pay in these increments is equivalent kind of to how much they had to pay for kerosene to light lamps and stuff, right? So this transformer here in the bottom left is specially designed so it can be remotely activated, so it'll cut off the power to any load that's attached to it. And then, so that's an incentive to keep repaying for your system. Once you fully repaid for it, it gets unlocked, and then the person can use it free and clear after that. And if a person stops repaying and doesn't repay for a while, it has to be repossessed, right? Oops, sorry. So our task was actually figuring out predicting based on an application form who would fully repay for their system, right? And as we were working on this problem, it raised a discrimination issue because in this part of the world, caste and religion are extremely highly correlated with the surname of the person. Okay. So this is something that we would not have understood if we didn't like, truly understand this part of the world, these people, and everything, right? So you actually have to be there and fully understand what's going on. We did end up developing some logistic regression model, got some results, but that's not the point, right? The point is what I was saying before. So it's important to actually go there, do a qualitative assessment. So this is one of the homeowners for whom the solar panel was installed. And we actually spoke to him, figured out what was actually good and bad and how it can be improved and so forth. So this is the final assessment that actually matters. Okay. So one last thing that I'll say before ending and taking questions is this whole nursing perspective gets us very far, but it actually misses one thing, and that's related to this concept called action research. So action research, first of all, centers the values of members of marginalized groups and includes them as co-creators. And it's a 5-step process, right? So the first 4 steps are exactly what consultants would do as well, right? So you kind of diagnose the problem, you plan the set of actions, you take those actions, and then you evaluate whether things are working fine or not, right? This would also be kind of like the control theory sort of loop, right? But there's this 5th step, which is the research itself, right? So that's stepping back and actually generalizing from solving that one problem and learning from it so that the next time, and then the next time you have other problems, you've learned something and then can actually apply those going forward. So, so that's the last step, I think, in what needs to happen in this curative approach. Okay. So the final sort of call to action is really accompany the people who you're serving in developing AI models, go beyond just curing and go for the full sort of caring version of things, right? So let me stop there. So thanks for being part of the audience. Just one shameless plug before I end. So as Ken mentioned, I recently self-published a book entitled Trustworthy Machine Learning. So the free PDF is available at trustworthymachinelearning.com, and it's also available as a paperback on Amazon. So if anyone wants to check that out. All right, so yeah, happy to take some questions. So maybe I can first look at the Q&A in Zoom, and then we can go to other questions as people want, right?
That's great. Go ahead to the Q&A, and then there may be some panelist questions as well after you're done. Thank you.
Yeah, absolutely. Yeah, so Jonathan, with epistemic advantages, is there a multi-armed bandit approach to optimize the use of everyone's advantages? That is a great suggestion. We have not done exactly that. We did something somewhat similar in a way. So many of you are probably familiar with the game Pac-Man, the video game. So there's two objectives. One is the clearing the board of all of the little pellets, and there's ghosts. And so if you eat these power pellets in the corners, then you can go and eat the ghosts, and that gives you more points. So what we wanted to do was actually train a reinforcement learning sort of or bandit sort of algorithm that would be moral in a sense. And so the morality was not to eat the ghosts and still complete the board. And the way we approached it was to take the strengths of both human demonstrations as well as what the system can learn on its own through self-play and so forth. And so we actually had two different strategies. One was the human who demonstrated how not to eat the ghosts, and then there was the scoring from the game itself. And so we actually were able to have a bandit that would kind of switch between the two in the appropriate sort of settings that eat the ghost, I mean, not eat the ghost when you're near the ghost, and then score the maximum elsewhere. So it can be done. For the specific question that you're asking, it's a great suggestion. We haven't done it, but if you want to do it, I think it would be a great problem to look at. Other question on China and the European Union leading in AI regulation efforts. Yes, absolutely. So the European Union has a draft regulation out for high-risk AI, which should be enacted really soon. And it actually leads to a lot of, yeah, I mean, disclosure requirements, other sort of things, especially in fairness and explainability. And not sure on China as much. I'm less familiar, but EU for sure, yes. Uh, so first of all, why is the US trailing behind? So one reason is in Europe, they kind of take human rights as a very important sort of aspect for any laws and regulations. So that's the kind of starting point in a lot of stuff that happens in Europe. In the US, there's a lot more respect for sort of businesses and commerce and stuff like that. And so that's one reason why US laws tend not to regulate so much on technologies and things like that. But yeah, I agree with you. Although there are, I mean, individual jurisdictions that are taking actions. So in Colorado, there was just a law passed for regulating the use of AI in insurance. In New York City, there was just a law passed on regulating the use of AI in hiring and so forth. So in terms of the question, is the curative approach better positioned to unify efforts? and create a global framework. I don't know if a carative approach is positioned to do that. It's a good question. I think things are starting to happen through the IEEE, through other sort of international bodies. So I think those are the places where things will come together. Um, yeah, I'm just thinking, I don't know what the care, because kind of the point that I was making is that for every problem, you need to kind of work on that problem to understand it and do the best that you can. Whereas regulatory frameworks need to be kind of more universal in a sense, right? So uh, one way to think about it maybe is that this action research approach, right? The learning that you do. So you work on a bunch of problems to their end, to the full capacity that you can to really solve the problem. But what you learn from them and then and you do like, let's say 10 or 12 of them in different problem settings and so forth, maybe there's a way to generalize from those to come up with a more common sort of regulatory framework. But it's a good question. I'm not sure. um, all right. Another question was, yeah, the curative approach you describe is very similar to human-centered or participatory design. Are there significant differences? Uh, so they're related, absolutely. Uh, the sort of differences, I would say, and I'm still learning, so I'm kind of learning as I go as well. So I don't have all of this background myself either, but uh, I think the difference is that the nurse isn't the patient, right? So when you're doing kind of participatory design, uh, the patient is kind of part of the process in terms of like giving you I mean, is also one of the designers in a sense. The nurse is working with the patient, understanding them, learning from them, but eventually it's the nurse who's carrying it out. So I think that's one difference, but yes, I think there's a lot of close relationships. So I wouldn't say that they're very different. And another maybe small difference, or maybe difference, is again, participatory design still can be narrowly focused, right? It can still be what do we need to do on the model itself. It might not consider the whole picture, so all the way from the very beginning to the very end. But again, it might. So that's a possibility. All right, then Pat Larson's question. If the discrimination issue is tied to a larger social issue, does taking care of the approach mean you insert your values into the model? Okay, so it won't be your values necessarily. It should be the values of the people that you are, I mean, working with. But even if it's technically less accurate, is correct. Yes. So even in that particular problem, we lost about 2% accuracy by not including the surname into the model. So we did try it. I mean, just to see what would happen. So yes, there's a couple of percent that you did lose, and that's the right thing to do. Right? So yeah, absolutely on that. Then Deborah Matthews' question, regulation. Can you imagine incentive structures? Yeah, that's the hard question. Like right now, a lot of machine learning researchers are very incentivized to get their papers uh, into these top conferences and stuff, right? And that doesn't leave room for doing all of the work, right? From the problem understanding and data gathering and data understanding. So a lot of the papers that are out there, they take some random data set, they downloaded it, and then what they cared about was how do I create some novel algorithmic twist on something, right? So how does that change? Uh, I can talk a little bit about even at IBM Research. When I first joined, there was much more of an emphasis on working with clients on problems and really working with them closely. And then about 4 years ago or so, at least in the AI part of IBM Research, there was somewhat of a shift, and there was much greater emphasis on pumping out papers. And part of that reason was that IBM wasn't being seen as one of these top AI research companies like Google and Facebook and stuff. So in Europe or these other conferences, we didn't have as many papers as these other companies did. And so our leadership wanted to make sure that we're seen in the same light for both for recruiting people, I mean, getting top researchers, but also from marketing reasons and a lot of other sort of reasons, right? So that switch is now coming back to so it's always kind of like a pendulum, I guess. So it's now coming back to working more with clients and so forth, understanding problems. So um, for us, in our internal motivations, it's because, I mean, if our performance reviews are tied to also having client impact and so forth, then there can be, I mean, reasons to do that. From other research organizations, academia, etc. I'm not sure what those motivations could be, how to best do it. So if anyone has better thoughts than I do, I mean, I would be happy to hear them.
Thank you, Kush. Tony, did you have a question?
I do. Thank you, Ken. And thanks for the excellent presentation, Kush. Really enjoyed it.
Great.
Early in the talk, you gave a kind of a prescriptive list of aspects of applications and underlying AI technology that would be sort of flags for things that maybe someone or an organization would think twice about working on.
Yeah.
But many technologies, including facial recognition that you mentioned as an example with IBM, are dual use or multi-use. I mean, the same face recognition technology to do surveillance could also perhaps identify people who are in a crowd who have medical distress or something like that.
Absolutely.
So how do you rationalize? Or do you go for the worst case scenario, but you're kind of throwing out the baby with the bathwater?
Yeah, no, I agree with you. So some people would argue that you just don't do stuff. I would argue that you have to have nuance to it, right? So again, thinking about the big picture, so there's a certain technological aspect, and then again, thinking about the entire process. So even taking a computer vision system that's trained for crowds and people and stuff, and tuning it for the medical distress detection versus something else, right? This part could be universal. It could be, I mean, multi-use, dual use, but then there's the tuning aspects. So I'm not saying not work on, I mean, things that are more fundamental and more core, but maybe people want to think twice about that end part, the last mile, because certainly you can identify what the use is. So yeah, I mean, I'm not one of those people who will say stop working on things because there could be a chance, some remote chance for a misuse, but there's a point in time where that use becomes apparent.
Thank you.
We're at the top of the hour. I think it's time to close the seminar. Kush, I want to thank you so much for that very interesting and informative talk. We also are learning, and we look forward to learning the points you've mentioned today with you going forward in the future. Thank you and good luck.
Yep, my pleasure.
Thanks, everybody. Have a good day.